Welcome to Ask and Learn.
Hello friends, here it is given a straight rack rest on a gear of radius 3 inch and attached to the block B as shown in the figure. At the instant theta is 20 degree. The angular velocity of the gear D 3 radian per second in clockwise direction and speeding rate, that is angular acceleration, is 2 radian per second square in clockwise direction. We have to find angular acceleration of AB and acceleration of block B. Let us start solving. We will use this vector notation. This is to be considered I cap. This is J cap. Counterclockwise K cap. So pay attention. Let point P on the gear and point Q on the rock be located at the contact point between them. Assuming let point P on the gear and point Q on the rack be located at contact point between them. Units we are using, because again and again we would not like to write inch for speed or velocity inch per second and for acceleration inch per second square. Now let us here, by using the geometry, position vector of PD three sine of theta I cap plus cos of theta j cap r b cube 3 upon tan theta cos of theta I cap sine of theta j cap. Theta is 20. Omega of gear is given 3 radian per second and alpha for gear 2 radian per second square minus k cap, that is clockwise sense. So velocity of P point will be omega gear into r, so 9 inch per second, and in vector form it can be written as say equation 1. Acceleration of P normal, omega square gap into R 27 inch per second square. So in vector form it can be written as AP normal 27 inch per second square say equation 2. Tangential acceleration of P alpha gar into R 2 into 3, that is 6 inch per second square, and in vector form it can be written as 6 inch per second square. Now we will do velocity analysis. Get to rect contact velocity of Q. Is equal to velocity of P 9 inch per second. Rect AQ V. Velocity of V towards right, acceleration of V towards right. Velocity of V can be written as 9. Now you have to equate the component along y direction, that is j cap. So 0 is equal to, so from here omega AB is 9 sine of 20 upon, so on solving this value will be 0.39742 radian per second in anti-clockwise direction. Now we will do acceleration analysis. Get to rect contact. Acceleration of AQ, tangential, acceleration of P, tangential, and this value already we have measured 6 inch per second square, and this is the direction. Acceleration of Q, normal, acceleration of P, normal, plus R omega square rod in this direction. Here angular velocity of rod will be AB minus omega t, which is 3.39742 radian per second. So acceleration of Q, normal, you may write 27, this value is 27, in this direction. Theta is 20, so you may write, otherwise theta you can also write, doesn't matter, 3 into 3.9742 square, 20 degree. So on solving it, this acceleration you will get 76274 20 unit, you know, inch per second square. So acceleration of AQ will be 6 cos of theta I cap j cap 7 6274 Sin of theta I cap j cap. Simplify it by theta substituting. Here theta you have to substitute 20 degree. So you will get, finally I am writing directly. So AQ you can write 8.2469 I cap 5.1153 J cap inch per second square. Now acceleration of V point, acceleration of Q plus acceleration of V with respect to Q. So it having the value acceleration of Q, it having the two, tangential and normal. So alpha AV K cap cross RBQ minus omega square AB RBQ vector. Substitute the value. This is along right direction only. 8.2469 I cap 5.1153 J cap inch per second square. Alpha AB K cap cross 7.7453 I cap minus 2.81908 J cap. This term is 0. Now simplify it. Sorry, this term. Now we have to substitute this value. Omega square. Omega AB is 0.39742 square and 7.74535 I cap minus now solving it. After simplifying, this equation can be written as 8.2469 plus 2.81908 alpha AB minus 1.22 I cap plus 5.1153 7.74 alpha AB plus 0.44526 J cap. Now equating the component along I and J, we can find the value. So equating components along J and I and solving. I am now rightly equating x and y component of this. You may write 5.1153 plus 7.74 535 alpha AB plus 0.44526 is equal to 0. So alpha AB you will get minus 0.71792 radian per second square. Now equating the I component of the above equation, we can write AB is equal to 8.2469 plus 2.81908.71792 minus 1.22332. So acceleration of P you will get 5.0 inch per second square. So answer of part A is alpha AB is 0.718 radian per second square in clockwise direction, and answer of B part is acceleration of B is 5.0 inch per second square and right. So this is the answer for this problem.